Hello friends, today in this video we are going to discuss about Bernoulli differential equation. It is of the form non-linear differential equation. Suppose it is non-linear, so in that case we can reduce to the linear form, and that type of differential equation is known as Bernoulli differential equation. So what is the exactly first order and first degree Bernoulli differential equation? dy by dx plus p of x y is equal q of x, but here as a multiple y raised to n is there, where p of x and q of x are arbitrary functions or may be constants. So here accept n is equal 0 and 1. But if we can observe that if n is equal 0 and n is equal 1, so in that case it is going to be linear. But let us understand before here Bernoulli differential equation. So Jacob Bernoulli was Swiss mathematician. So that was the Swiss mathematician. He contributed to the field of elasticity theory and the mathematical probability. So again, he has more contribution in the mathematics field. So if n is equal 0, so in that case what it is going to be? Dy by dx plus p of x y is equal q of x, and that is their standard form, so linear. If n is equal 1, so what we can say? Dy by dx plus p of x y is equal q of x1. So again we can say that p of x y is equal q of x1. So in that case what we can say? Dy by dx plus p of x minus q of x y is equal 0, and that can be written as dy by y plus p of x minus q of x dx is equal 0, and this is what exactly it is reduced to the variable separable. So that means we can find it's the general solution. So what we can say that in that case n is equal 0 and is equal 1, then it is going to be linear. So in that case we are not going to talk about the Bernoulli differential equation. So accept these two cases, n is equal 0 and n is equal 1. So in that case what we have to do? So divide by y raised to n. So whatever we have on the right hand side, that is y raised to n. So divide by y raised to n. So what we can say? Y raised to minus n is there. So we can say y raised to minus n dy by dx plus p of x y raised to minus n is there, but 1 is there, so we can say y raised to 1 minus n is going to be there. Here it is going to be y raised to minus n, and this is going to be cancelled. So therefore we have this one form. But here whatever we have multiple of x, that is going to be new variables, say that is t. So in that case we can convert y in terms of t. So here 1 minus n y raised to 1 minus n minus 1 dy by dx is equal to dy by dx. But here y raised to minus n dy by dx is equal 1 divided by 1 minus n into dt by dx. Now our equation number 2 becomes, here in that case what we can do? Instead of that we can write that 1 divided by 1 minus n dt by dx plus p of x dt by y raised to 1 minus n is going to be t and is equal q of x, and this is what exactly linear. If it is linear, then we can solve the previous method. How we can find the linear solution, how we can find the general solution, that thing already we have discussed in previous. But here also we see solution of the Bernoulli differential equation. So let us see first question, dy by dx plus y is equal minus x by 1. So this differential equation can be written as dy by dx plus y is equal minus x y raised to minus 1, which is Bernoulli type. Now you can observe that they were standard form. That is the q of x into y raised to n. But here again power n is what here, that is negative. If the power is negative, then in that case we are not going to say that the given differential equation is in fact degree. For example, if I say x square plus 3 divided by x raised to, this is the 4. So what can we say that about the degree? Can we say that this is a polynomial? So answer is no, because polynomial contains only whole power as a whole number. So this is what exactly power is going to be negative. So therefore it is not a polynomial. So same argument is there. Minus 1 is going to be there. So depending variable has power negative. So we can say that is what exactly not a degree in terms of we are talking about. Okay, so here dy by dx plus y is equal minus x into y raised to minus 1. So which is the Bernoulli differential equation of the type. And so what we have to do, we want here only function of x. So I have to remove y raised to minus 1. How we can remove it? Divide by itself y raised to minus 1. So it is going to be y into dy by dx plus y square is equal minus x. Recently I have just told you what can be, so here whatever it is multiple of x or whatever it is function of y, it is going to be new variable. So here function of y, that is the y square is there. So in that case we are going to letting t. So 2y dy by dx is equal to dy by dx. So now equation 2 becomes, so what we can say, instead of that we can write that 1 divided by 2 into dt by dx plus y square is going to be t is equal minus x. But here 1 by 2, I want here constant 1, so that means I have to multiply the 2 throughout. So dt by dx plus 2t is equal minus 2x, so which is what exactly linear. So now compare with their standard form. So we can say p of x and q of x is there. So integrating factor is equal e raised to integration p of x dx. So here e raised to integration p of x is nothing but 2 into dx. So it is going to be e raised to 2x. The general solution is given by depending variable. So depending variable is t multiply with integrating factor is equal integration q of x multiply with integrating factor into dx plus c. So here you can put your integrating factor and q of x is there. After integrating you will get this one, and finally t is replaced by y square, so we get this one, and this is final answer. Degree is 1, order is 1. So in general solution we must have one arbitrary constant. Now let us see another question. Solve sec square y is into dy by dx plus x tan y is equal x cube. Now it is clear that this is the non-linear. How we can say that this is the non-linear? Because dy by dx has a multiple sec square y. This is again more than 1 degree. Okay, so product is there. So ultimately we can say that these terms says that it is the non-linear. So first what I have to do, just divide by sec square y for our simplicity. In other ways, what the examiner can ask, dy by dx plus x into, if I write tan y divided by sec square y is equal x raised to cube into sec square y. So this can be asked either way. Suppose this is the given, so our target is to what we have to remove this function. How we can remove this one? Divide by sec square y. So in that case going to be this one. So now our case is what exactly Bernoulli form. So here what is our next target? So here second term has function of y, that is the tan y, and letting tan y is equal t. So we get here sec square y into dy by dx is equal to dt by dx. So it is going to be here dt by dx plus x into t is equal x raised to cube, and this is what exactly linear. So we can say this is the p of x is equal x and this is the q of x. So therefore integrating factor is equal e raised to integration p of x dx. So we get here e raised to x square by 2. Therefore the general solution is given by, so depending variable t multiplied with integrating factor is equal integration q of x, that is x raised to cube, multiplied with integrating factor, that is e raised to x square by 2 dx plus c. The c is nothing but integrating factor. Now to integrate, here take x square by 2 is equal u. So x into dx is equal, that is only du. So x square can be written as only 2u. So this is the same, and here x raised to cube can be written as what? That is the x square into x, but x square is what exactly? That is the 2u. So I write that here x cube can be split here, x square, and here that is the x, and this is going to be what exactly? Du, and here x square is there, so we can say this is the 2u. So 2u into e raised to u du plus c. But after integrating, you will get this one, sorry. So in that case, u is replaced by what? That is the x square by 2, and in that case you will get this one. Again you can assume that 2 as LCM, so x square minus 2. So in that case 2 will be cancelled out, but here 2 is there. Again 2c dash, but 2c dash is going to be new constant, and this is what exactly general solution. And these two examples is homework. Solve xy minus dy by dx is equal y raised to cube into e raised to minus x square. So answer is that. And another question, dy by dx plus 1 divided by xy is equal x cube y cube. Again this is what exactly Bernoulli case, and in that case what you have to first focus, y raised to, I want here only function of x, that means I have to divide by y raised to cube, and here again same argument you have to give, and you have to give that divide by y raised to cube, and in that case taking the assumptions you will get the linear differential equation. So our conclusion says what? If the given differential equation is Bernoulli, so in that case we try to convert in the linear differential equation. That will be the final, and in that case we can proceed to get the solution. Thank you.